Hi everyone, welcome back. In this lecture, we will learn how to use the try-except block to handle exceptions in Python. This try-except block is the heart of Python's exception handling system. It helps us detect and manage errors gracefully instead of crashing the entire program. Let's start with a simple real-world scenario. Imagine you are using an ATM. You insert your card, enter the PIN, and try to withdraw 10,000 rupees. But your balance is only 500 rupees. What does the ATM do? Does it crash or explode? Number it shows a message, insufficient balance. It handled the error in a user-friendly way. That is the idea behind exception handling. So in Python, we use the try-except block to achieve this kind of safe behavior. Let's dive deep into how this actually works. So what is a try-except block? A try-except block is a control structure. It's made of two main parts. First, the try block. This is where we write the code that might cause an error. Second, the except block. This is where we define what to do if an error actually happens. Here's the flow. Python tries to execute the code inside the try block. If everything runs smoothly, it skips the except block. But if an error occurs, Python jumps straight to the except block and handles it from there. Let's break this down even further. Let's look at the structure of a try-except block. Let's imagine we want to divide two numbers, but the second number might be 0. So here's what the structure looks like. We write try followed by a colon. Then on the next line, the risky code, like dividing one number by another. Then we write except followed by a colon, and inside that block we tell Python what to do if an error occurs. The idea is simple. Try to do something risky. If it works, great. If it fails, don't crash, just handle it. Let's now open PyCharm. Let's create a new folder in the project and name it as exception. Right click on the exception folder, choose new, then Python file. Let's name the file try_except_example. Now let's start building our program from the top. We begin with user input. Let's say we want the user to type two numbers. Then we divide them and print the result. Let's first create a variable called num1. We set it equal to integer, then parentheses, input function. Inside the quotes, we write enter the first number. This line will show a message to the user. Whatever they type will be read as a string, then converted to an integer. Now do the same for the second number. We create a variable called num2, set it equal to integer input. With the prompt, enter the second number. So now we have two numbers, num1 and num2. Let's try to divide them. Let's now begin our try block. Type the keyword try, then colon, and indent the next few lines. Inside the try block, we divide num1 by num2 and store the result in a variable called result. Then we print the result with a message. Let's type result equals num1 divided by num2. Then we type print, and inside the message we write the result is result. This is our main operation. We are expecting Python to perform the division and print the result. But what if something goes wrong, like division by 0 or entering a string instead of a number? That's where our except blocks come in. So first we handle division by 0. We write except 0 division error, then colon. Inside this block, we print you cannot divide by 0. Please enter a non-zero number. This block will run only if Python encounters a 0 division error. Let's also handle unexpected errors, like if the user types letters instead of numbers. We write except exception, then colon. Inside this block, we print something went wrong. Please enter valid numeric values. This catches any other type of exception, not just division errors. Let's test our program with valid input. Right click and run the program. First it asks, enter the first number. Let's type 10. Then it says, enter the second number. Let's type 2. Perfect. Now Python goes into the try block. It divides 10 by 2, which is 5. So we see this output on screen. The result is 5.0. No errors. The try block ran successfully and the except blocks were skipped. Awesome. Let's now run the program. Let's now test what happens when we divide by 0. Click run again. It asks enter the first number. We type 10. Then it asks enter the second number. This time we type 0. Now Python enters the try block. It tries to perform 10 divided by 0, but division by 0 is illegal in math. So Python throws a 0 division error. Now instead of crashing, it jumps to the except 0 division error block. We see this output. You cannot divide by 0. Please enter a non-zero number. The rest of the code is skipped, but our program didn't crash and we handled the issue gracefully. That's the beauty of exception handling. We stay in control even when the user makes a mistake. Let's now test a non-numeric input. Before that, we need to move this user input code inside the try block. The try block should contain the risky code. Right, let's cut these two lines and paste them inside the try block. So basically, we are testing the use case. Like if the user enters a string instead of a number, then this int function fails to convert into a number and throws an exception. That exception will be handled here. Let's see this in action. Run the program again. First prompt, enter the first number. We type hello. Python now tries to convert that to an integer but fails. It immediately jumps to the general except exception block. And we see this output, something went wrong. Please enter valid numeric values. This time the program didn't even reach the division step. It failed early and we still handled it smoothly. Let's now recap what we learned. The try except block is used to handle errors. It lets us write safe, user-friendly programs. Inside the try block, we put the code that might fail. If it works, Python runs it normally. If an error occurs, Python jumps to the first matching except block. We can have specific blocks for known errors and a general block for unexpected issues. We ran 3 test cases. A valid division, 10 divided by 2, gave us 5.0. A division by 0 showed a helpful error message, and non-numeric input triggered the general exception block. This is how Python handles problems without crashing. In the next lesson, we'll go deeper and explore the else and finally blocks. 2 advanced features that complete the exception handling flow. Thanks for watching and keep practicing.